In a quiet corner of North Florida, a 4,000-acre lake has vanished. Not slowly evaporated by the sun, not leached away over months. It has drained, like a colossal bathtub, into a hole in its own floor. As of late spring 2026, Lake Jackson, a landmark body of water just outside the state capital, is a vast expanse of cracked mud, skeletal tree stumps, and drying lily pads. Over 5 months, an estimated 12 billion gallons of water funneled straight down into the earth, disappearing into the upper Floridan aquifer. Now, in a scene that borders on the surreal, people are walking their dogs and hunting for fossils at the bottom of a 28-foot wide sinkhole that just a year ago was buried beneath the waves. The event began quietly, almost unnoticeably, during the week of Thanksgiving 2025. Leon County was in the grip of what the National Weather Service would soon classify as an extreme drought. The rains had stopped. The streams that fed the lake's 42-square-mile catchment basin had dried to a trickle, then to dust. But beneath the surface of the lake, in a deep depression known to locals as Porter Sink, something far more dramatic was unfolding. The thin plug of clay and sediment that normally sealed the lakebed, holding back the immense weight of the water, was beginning to lose its foundation. Deep below, the water table of the aquifer had dropped, removing the hydrostatic pressure that propped up the plug from beneath. The weight of the lake was now unsupported, and it began to fail. By the last days of November, observers along the shore noticed a current where there should be none. The water was being pulled toward the center of the southern basin. A vortex formed. Within days, it was a cascading waterfall, roaring as thousands, then tens of thousands of gallons per minute poured into the opening chasm. The sound was a constant low thunder. Fisheries biologist Michael Hill, with the Florida Fish and Wildlife Conservation Commission, who had witnessed a similar event in 2012, described the water level dropping by several feet a day. For a lake that covers over 6 square miles, losing feet of water in a day is not a leak. It is a catastrophic failure of the basin itself. The transformation was apocalyptic. What was once a premier spot for largemouth bass fishing, a place of pontoon boats and weekend getaways, became a geological exhibition. The water receded, exposing a landscape that had been hidden for years, sometimes decades. Old boat motors, lost fishing lures, and centuries of accumulated debris lay exposed on the drying muck. But most striking was the hole itself. Porter Sink, now fully open to the air, was a 28-foot deep, cavernous wound in the earth, its limestone sides slick with algae. Curious what you think about this. Actually, the idea that you could be water skiing one week and excavating a chasm in the same spot the next. By early 2026, the temporary lake was gone for good. The vast majority of the 4,000-acre basin was dry enough to walk on, sprouting new grasses and plants in the nutrient-rich sediment. The lake had not just receded, it had been swallowed. To understand how a body of water the size of a small town can spiral down a drain, you must first understand the ground beneath Florida. This isn't solid bedrock. Much of the state sits atop what geologists call karst terrain. It is a landscape made of soluble rock, primarily limestone, that has been chewed away by mildly acidic groundwater over millions of years. The result is a subterranean world, a honeycomb of caves, conduits, and voids. Lake Jackson is located directly on what is known as the Woodville Karst Plain, a region famous for this Swiss cheese geology. It sits in a closed basin, meaning no rivers or streams flow out of it. For millennia, the only way water left was through evaporation or by seeping slowly into the ground. But Lake Jackson is different. It has 2 main drains built into its floor, Lime Sink in the northern portion of the lake and the much larger Porter Sink to the south. These sinkholes are not permanent openings. They are natural weaknesses in the limestone, typically covered by a layer of sand, clay, and organic muck that acts as a natural plug. For this plug to hold, it needs support from below. That support comes from the upper Floridan aquifer, the vast underground reservoir that supplies drinking water to millions. When the aquifer is full, the water pressure pushes up against the bottom of the lake's clay liner, keeping it stable. But during a severe drought, 2 things happen. First, less rain falls to fill the lake from above. Second, and more critically, cities and agriculture pump more water out of the aquifer from below. The water table drops. The pressure supporting the lake bottom vanishes. Suddenly, the only thing holding back 12 billion gallons of water is a thin, unsupported layer of mud. Under that immense pressure, the plug gives way. It collapses downward into the empty limestone caverns below, and the lake begins to pour directly into the aquifer. The flow rate can be staggering, reaching up to 10,000 gallons per minute during the peak of a draining event. That's enough to fill a backyard swimming pool in under 2 minutes. Over weeks and months, this relentless drain pulls the entire lake into the plumbing of the earth. But this is the part of the story that most reports miss. The water is not gone. It has simply changed addresses. It has entered a hidden underground superhighway. For decades, scientists suspected a connection between the disappearing lakes of Tallahassee and the Great Springs to the south, but they couldn't prove it. The journey seemed too far, the path too complex. That changed on September 19, 2017. A team of scientists, led by Dr. Seán E. McGlynn, a hydrogeologist and the technical director of McGlynn Laboratories, decided to map this invisible river. They rowed a boat out to the center of Porter Sink, which was then underwater but still actively seeping. For precisely 6.5 minutes, they pumped a bright fluorescent tracer dye called rhodamine WT into the sinkhole. Then they waited. Their hypothesis was that the water was traveling south, through the vast network of conduits within the Floridan aquifer, towards one of the largest and most famous freshwater springs on the planet, Wakulla Spring. The spring, located 19 miles south of Lake Jackson, is a massive first-magnitude spring, gushing hundreds of millions of gallons of crystal-clear water every single day. Dr. McGlynn, working alongside hydrogeologists like Tom Greenhall from the Florida Geological Survey and Dr. Ming Ye from Florida State University, set up sensors at the spring to detect the faintest trace of the dye. For an entire month, nothing happened. The water from Lake Jackson had vanished into the earth, and its trail went cold. Then, 35 days after it was poured into the muddy bottom of Lake Jackson, the unmistakable fluorescent signature of the rhodamine dye appeared, erupting from the main vent of Wakulla Spring. The connection was proven. The journey was mapped. The water traveled 19 miles, or 30.6 kilometers, entirely underground. The team's data, officially published in the December 2024 issue of the Journal of Cave and Karst Studies, co-authored with the late geoscientist Dr. Alan W. Niederroda, showed the water moved at an average speed of 0.55 miles per day. Lake Jackson wasn't disappearing. It was relocating. It was undertaking a month-long 19-mile journey through a pitch-black labyrinth of limestone caves to be reborn as the cool, clear water of Wakulla Spring. To think that a public park and a tourist destination is being directly fed by a lake nearly 20 miles away through a plumbing system no one can see is extraordinary. It reframes the entire hydrology of the state. If you find these kinds of deep dives into the hidden systems of our planet interesting, a subscribe is one way to make sure you see more of them. The work these scientists did effectively drew a line on a map where before there was only a question mark. And that leads to the central mystery. This draining is not by itself unnatural. The indigenous Muscogee people who lived here for centuries called the lake Okeeheepkee, which translates to disappearing waters. They knew the lake had a habit of vanishing. In fact, when the Spanish explorer Hernando de Soto and his expedition wintered in the area in 1539, his chroniclers described the location not as a lake, but as a vast grassy plain. Historians now realize de Soto didn't discover the lake because he arrived during a dry-down cycle. He was camping on the lakebed. The first formally documented drainage in the modern era was reported in a local newspaper in February 1829. After that, a clear pattern emerged. The lake would completely drain roughly every 20 to 25 years. Major events were recorded in 1836, 1860, 1886, 1907, 1932, 1957, and again in 1982. It was a generational event, something you might see once or twice in your life. Then, at the turn of the millennium, something changed. The clock broke. The reliable 25-year cycle shattered. A major drain event began on September 16, 1999. In May of 2000, Lime Sink, the other drain, opened up and finished the job. Then it happened again. Porter Sink drained the lake in June 2006. Again in June 2012. Another major drydown began on June 6, 2021. And now, the most recent and severe collapse began in late November 2025. The interval between these catastrophic drainages has collapsed from once a generation to every few years. The question that is consuming hydrogeologists in Florida is why? What have we done to so drastically accelerate this ancient natural cycle? The answer is likely a combination of two powerful forces: climate change and human water consumption. The droughts in the southeast are becoming more frequent and more intense. Less rainfall means the lake and the aquifer are not being replenished as they once were. At the same time, the population of Florida has exploded. More people, more agriculture, and more industry all draw water from the same source, the Floridan aquifer. This relentless pumping lowers the overall water table, making the aquifer less able to support the lake beds above it. It's a double blow. Less water coming in from the sky, and more water being pumped out from below. In February 2026, the Northwest Florida Water Management District issued Water Shortage Warning Order 26001, a direct response to the dire conditions. It was a formal acknowledgement that the system is in deficit. The Lake Jackson drydown is not an isolated incident. It is the most dramatic symptom of a much larger region-wide water crisis. It's a story worth sharing. Low-key send this to a friend you think might find this hidden connection fascinating. This accelerated cycle has profound impacts, both for the ecosystem and the people who live around it. The most immediate effect is on wildlife. As the water funnels into Porter Sink, tens of thousands of fish, largemouth bass, bluegill, bream, and gar are trapped in the shrinking pools. For predators, it's a banquet. Wading birds like egrets and herons flock to the shallows. Alligators, normally spread out across 4,000 acres, are forced into close proximity in the remaining deep spots like Church Cove and McInnes Arm. It is a moment of intense, brutal ecological concentration. But according to the Florida Fish and Wildlife Conservation Commission, this process, while chaotic, is ultimately healthy for the lake. They call it an ecological reset. When the lakebed is exposed to the sun and air, the deep layer of rotting organic muck oxidizes and compacts. This firms up the lake bottom, creating the hard, sandy substrate that native sport fish like largemouth bass need for spawning. When the lake eventually refills, the fishing will be better than ever. But it's hard to focus on the long-term ecological benefits when your lakefront property now overlooks a field of mud, or when your boat dock ends 100 yards from the nearest drop of water. The human impact is jarring. The local economy, which depends on recreational fishing and boating, takes a significant hit. But the story gets stranger. During the June 2021 drain event, as the basin emptied, a discovery was made on the newly exposed ground. 2 human skulls and other skeletal remains were found, turning a natural phenomenon into a potential crime scene. The lake, in its emptying, was giving up its darkest secrets. In the most recent 2025 to 2026 event, this has given way to a kind of post-apocalyptic tourism. Locals and amateur paleontologists are now venturing deep into the basin, even climbing down into the 28-foot crater of Porter Sink itself, a place normally under immense water pressure. They are searching for artifacts from the Muscogee people, remnants from the De Soto expedition, and the fossilized bones of ancient mammoths and mastodons that roamed this land during the last ice age, when the lake was also likely dry. They are, quite literally, walking on a timeline of millennia laid bare by the draining waters. And what about Wakulla Spring, the recipient of this massive water transfer? The spring is already designated as an impaired waterway by the Florida Department of Environmental Protection. The primary issue is an increase in nitrates, largely from agricultural fertilizer and septic tank runoff, which fuels algal growth and darkens the once famously clear water. Now, it is receiving 12 billion gallons of lake water, which has a completely different chemical composition. It's warmer, more organic rich, and carries different nutrients. What are the long-term consequences of injecting this massive bolus of surface water directly into the heart of one of the world's most significant freshwater springs? Dr. McGlynn, in his 2020 Wakulla Spring Darkwater report, noted the complexity, stating, "At Lake Jackson, the dye traveled 19 miles to Wakulla Springs, all in underground caverns. The Wakulla Spring shed is riddled with caves. We have mapped so many that the Wakulla Spring shed has the longest mapped underwater cave system in the world. Introducing billions of gallons of foreign water into the world's most extensive mapped underwater cave system is an uncontrolled experiment with unknown variables. This event forces a systemic reevaluation. If a 4,000-acre lake can vanish every few years because of pressure on the aquifer, what does that mean for the houses, roads, and cities built on that same unstable karst terrain? The Floridan aquifer provides drinking water for nearly 400,000 people in the Tallahassee metro area alone, and millions more across the state. The disappearance of Lake Jackson is a visible, dramatic warning that the entire system is under an unprecedented level of stress. The stable ground and reliable water supply that Florida has been built upon may not be as stable or reliable as we have assumed. The disappearing lake is a canary in the coal mine, signaling a fundamental shift in the state's environmental baseline. For now, the future of Lake Jackson is uncertain. The Atlantic hurricane season, which begins on June 1st, could change everything. A single large tropical system could stall over the Florida Panhandle and dump enough rain to refill the entire 4,000-acre basin in a matter of days. Without that, the lake will likely remain a grassy plain throughout the summer, just as it was when Hernando de Soto arrived nearly 500 years ago. Geologists know that sediment will eventually migrate back into Porter Sink, plugging the drain once again. But no one can say when that will happen. Will it be months? Years? And when the plug does reform, will it be strong enough to hold? Or will it be a weaker patch, destined to fail during the very next drought? The cycle has been broken, and the new rules have not yet been written. So, 3 critical questions hang over this empty basin. First, how long will Lake Jackson remain dry, and what determines the timing of its return? Second, is this accelerated cycle of draining the new normal a permanent feature of a landscape altered by human activity and a changing climate? And third, what does it mean for the health of the entire Floridan aquifer that one of its largest sister springs is now periodically being force-fed an entire lake's worth of water? The answers are still being pieced together. But one thing is certain. The water that filled Lake Jackson on Thanksgiving morning of 2025 is not lost. Right now, it is moving silently through the pitch-black limestone conduits of the Woodville Karst Plain, somewhere between Tallahassee and the coast. It is traveling at just over half a mile per day, a slow, invisible river on a 19-mile journey south. Porter Sink is still open. The aquifer is still receiving its water. And somewhere deep in the earth, the next installment of Lake Jackson is on its way to Wakulla Spring.